So in today's video I want to talk about something that matters a lot to me actually. I want to talk about backing up software of vintage equipment, be it a hi-fi, a video player, perhaps an audio streamer, maybe a TV. This sort of software is now very hard to come by. A lot of these devices ended up in landfills, and a lot of the original manufacturers don't support the devices anymore. They have no interest in it. It's not financially viable for them to have interest. They won't open source the dumps of the ROMs. So it's very hard to fix these devices now. If you went back to something from, say, maybe the 50s, that was quite simple and it used tubes or what have you, you would have other issues because tubes are becoming scarce now. But it would be simpler to fix. Maybe even the 70s, the first discrete logic devices would be relatively simple to fix. But you get into the 80s and the 90s, and suddenly you get into the world of software and firmware, and it can become very hard to find stuff. If you get into the more newer stuff, the 2000s, sometimes that stuff is available online still, and sometimes it's programmable over USB, so it's not too bad. But that sort of 80s, 90s era, that's the sweet spot where it can be very troublesome to find software or backups of the software. So on screen now, what we've got here is something that I've purchased. We can see I've purchased this a little while ago now. It's coming up to a year ago. This isn't necessarily the kit you need to buy, but this is just the one that I bought. Well, it's £58 and £59. And the key here is it's the TL866 Plus programmer. And the reason I went for this particular kit is it came with a IC extractor tool, it came with the USB cable, and it came with a range of different adapters for different styles of chips. But if you were to put TL866 Plus, if you were to put that in, you can see you can get different kits at different prices. Some are more expensive. Some, if it's just the programmer on its own, is a little bit cheaper. There's one there for £48. But the adapters are really the key. So you're better off trying to get one of the bigger kits with all of the adapters, so you don't have to worry about buying them separately. And of course, you don't need to buy them from Amazon. You can buy it from anywhere. But I will put a link to the particular kit that I purchased in the description if you want to purchase that kit too. With that out of the way, let's get on with showing you how it functions. So before I can actually show you the programmer and show you how it functions, it actually needs its own software to run. So what we will do is, this is a completely blank install of Windows 10. I installed it an hour ago, so there's no trickery here. This will be the exact process for anybody that's never used this before. So we'll go to a browser. This particular one is Edge, and we'll type in what it is, which is the TL866 II Plus. And I should probably put download on the end. And then we can see the top link is to the xgecu.com, which is what it is. And be careful here because it might take you to the old version, so we need to find the new version. So let's have a look. So you can see it comparing the versions, and here we go. We've got the TL866 II Plus application software. So we'll click that, or click somewhere on there. Yep, there we go. Now you may notice this website is quite slow, and I think it's because it's possibly hosted on a slow server or in China. We can see we've got the user manual here, and we can see this is the latest version of the software. And ideally we want to download from perhaps an overseas server. That might suggest something closer to us. Okay, so it's taken me to a MediaFire link. Okay, good work. And what we should do is we should see Let's go for the zip, that's probably the best approach. And the software is this XG Pro software, and we can see this one was March of this year. We're in June now, so it's only a couple of months old, so that's fine. So I'm going to click that. I'm going to click download. Got our first horrible pop-up of the day, so we can close that. But we can see that that is downloading in the background. Before you give up on this, you might also want to just download that user guide as well. Got a second pop-up of the day, so we can get rid of that. And hopefully that is downloading. It's a bit hard to tell here. Let's have a look. Yes, it has. Okay, good. So that's downloading the software. So once you've found your downloaded software, in this example it's just gone to downloads, which is fine, you'll need to extract the zip. So I'll just use the built-in Windows zip extractor for now. And we can see we've now got the setup file, so I'm just going to double click that. It's not too happy to run this, which is not overly surprising. I will caveat this and say that obviously be very careful with what you're downloading, what you're installing. Normally you wouldn't just do this, but I'll do it anyway. Now that's interesting that it's saying drive D. I'm not sure where it's getting that from, so let me just have a quick look. Yeah, that can't possibly be correct because that doesn't exist. Surely that will fail. Yes, it fails. Okay. So what you're going to want to do is you're going to want to change that. What I will probably do, so we'll go to this PC, go to the C drive. I'll make a new folder and I'll just call it IT for now. So there's no spaces, nothing to worry about there. And we'll change that to C:\IT / and then what they want to call it. So we'll say install it there, which I think is actually an extract more than an install. Okay. No, it has indeed installed it there. Interesting. So we can see here that there's a driver required for it. So I'm going to say install for that. I'll click finish. If we go and check that directory, yeah, and it actually comes with the user guide in the install as well. Now, you may have preferred to have said actually for it to install it in program files, so either program files or program files x86. I'm not 100% sure if this is 64-bit or 32-bit software. What does it say? 32-bit. So you would have ideally stored that in the x86, so you would have said C:\/ program files x86. You could have taken that, copied and pasted that with a backslash like that, and installed it there. Would have been the better idea. Okay. So as you saw, I just double clicked the shortcut that was on the desktop, and on the first run it says no programmer found because it's not plugged in yet, and it will ask you what you want to do in terms of a demo. So I'm going to say the one we've got, which is the II+, and that would be the software sort of ready to go. So I'm going to close it down again, and now I'm actually going to connect the programmer. So let me do that now. It's just a standard USB cable. It's a USB-A to USB-B. I imagine it probably runs on USB 2.0. So we'll open up the software again. It says please reflash the firmware. Okay, and I think you need to do this every time you first install. You don't need to do it a second time. And of course, if you download a newer version of the software, there'll be a newer firmware. So there we go. We've got the reflash firmware option there under tools. Please carry out this upgrade. Yeah. Okay, so that sounds fair enough. So it thinks the current version is 4.2.1.126. So it'll be interesting to see if we end up with a newer version. Might do. Okay, so that's the flash successful. And yes, I guess we have, because we've gone from 4.2.126 to 4.2.128. So we've now got a newer firmware. So I'm just going to close and reopen the software again. And we can see we had no warnings that time, and the programmer is essentially ready to go. So that is how you set up the programmer. Just before we move forward very quickly, I also want to just say that what you should probably do is go to Tools and then do a System Self-Check. Make sure there's nothing in the programmer, of course, which there probably shouldn't be because it's brand new to you, and just do a test. And we can see here that mine's come back fine, normal, so I'm happy with that. So we're ready to continue. In a somewhat recent video, I tried to fix this VX7000 VHS recorder, and unfortunately I've been unsuccessful at this time. But one of the things I did notice is that I've got two AV9000s with the VHS in, and I've got two VX7000s, which are obviously VCRs. So I've got four different VCRs of this type, because they're all based on the same chassis. And they've actually all got marginally different versions of the software in them. When I did some research, which I'll put towards the end of the video, I realised that I actually had most of the versions of the software that B&O produced. So I thought it would be a good candidate to take the software chips, back them up and archive them, because it might help other people. I know it's slim, but it might. So on the bench now is the one of the VX7000s, and the best way to get to the software chip is actually on the underside. So let me pause the video, turn it over, and we'll go from there. With the VCR now upside down, I'm just going to remove all of the relevant screws. Okay, so I think somebody's been in here before, because I don't recall taking all of the screws out of the bottom of this one. So it looks like somebody else has been here before. The belt, let's have a quick look. Belt doesn't look too bad. I'm also not convinced it's sitting where it should be sitting, but that's a story for another day. So the software chip on this particular device is hidden under here somewhere. So let me just take the two screws out that hold this board down. Sorry, 3 screws. Okay, I'm just going to turn it round so we can get a better angle at this. Okay, so with the VCR switched round, I'm just going to try and lift this board. And I don't remember quite how this goes now because it's been a little while since I've looked at this. I think, what have we got? We've got sort of plastic pegs that seem to go through the board, and the screws are obscured by the panel, which makes it a little bit awkward. I'm not sure if these plastic pegs are going to be able to... Oh yeah, they pop. Okay. Obviously be a bit careful when you're doing this with your device. You don't want to be rough with it like I'm being, but sort of past the point of caring with these things at the moment. So there we go. So now I should be able to just carefully pop this board. And I'm going to move the camera because there's not a lot of wiggle room on the cables. And I'll show you what we're trying to get to. Okay, so now we're a little bit closer. I can show you. So if I lift this board up, you'll see there's actually a software chip in here. See this big EPROM here? That's the software chip, and that's what we want to get out. Now, obviously officially you would try and use a proper chip removal tool, but if you don't have the clearance, you might use a screwdriver. You may even use a bent screwdriver to sort of get a bit of a better angle at it. because if you kind of try and get in there with a little flat head, you may see that you don't quite have the angle you want. And obviously you don't want to just wrench up on it, you want to try and be very careful and try and go from both sides. I'll just see if I can show you me loosening it ever so slightly. I'll try and hold that cage because I don't want that to lift. So here we go. Just putting a little bit of pressure on it. You can see it's all flexing, so I might need to do this off camera, but that's the chip we're aiming for, and we're going to try and get that one out gently. Okay? So I've just been levering at this gently just for a couple of moments there, and I did manage to get it out. So once you've lifted it, or once you've levered it, it should just lift out. You can see me just lifting it out here, and all of the pins all seem to be okay, nothing got bent. And like I say, the key is don't rush it, because you do not want to bend the pins. If you do, it's not the worst thing in the world. You can bend them back, but obviously if you keep fatiguing them, they will snap, so please try not to do that. So here we have the chip, and let me just see if I can bring that in, get that to focus maybe. Okay, it doesn't seem to focus any closer than that, but you can see it says VTR, and I think it says 458X maybe. And then it says what would be a B&O part number underneath, 8342605 or something. And then I think it says V2.3, something like that. And it says UIP, and I don't quite know what UIP means, but there we go. So we can see this is approximately software version 2.3 for this VCR. Now, if you're just backing up, that's absolutely fine. You don't need to remove this label. However, you do need to know what the chip is. And the only way you're going to know that is probably by actually looking at the chip. And sadly, what we need to know is just underneath the label. So I'm going to stop the video quickly, take a quick photo for my reference, and we're going to try and remove this label in a moment. So in order to try and remove this label, the first thing to do would be to use something hopefully non-invasive. So you would use like perhaps a plastic trim tool from a car kit, something like that. Just something to get underneath the end of this label. Now this one, I haven't touched it, but the glue is so old that it's just lifting. So actually this is perfect. We can just lift that label and we can see exactly what type of chip this is, and we'd be able to go on about our day. So let's do that for now. Let's just say, okay, we know what it is. It's an M27, I think that says C512. I'll just stop again and take a quick photo of that. Okay, so now we know what the chip is. In a moment, when we fire up the software, we'll see what we have to do. But essentially, with the chip, we'll have to put it in the programmer. And chips are directional. You'll see that there's like a little, let me move it to a part of my hand that makes it more easier to see that. There's like a, there you go. There's like a little U in the top of the chip. And obviously the text is the correct way up as well. So the top left is pin 1. And we can see that the little U is the top of the chip. And if we look at the programmer, it's actually got some sort of embossed symbolism there. And you can see that it says IC chip and it shows the U at the top. So you would think that it would go in the uppermost part of the ZIF socket, and then you would just flick that down. That will lock the chip in. It's not always true. Different chips sit in different places, but the software will show you that. So we'll move over to the software now and go from there. So we're back in the software now, and what we need to do is we need to select the IC. So we're going to come up to select IC and we're going to click the previously selected one. Now if you wanted to, you could go through manufacturer and look for it manually, but there's no need to. You can just go search device and we're going to type in M27C512, and we're going to see we've got a couple of options here. Now it's come up manufacturer and you can see it's gone to AMD, which is not correct. We're actually going to look for ST because that was the brand name on the chip in this particular instance. And we can see that we've got two options. We've got PLC-C32 and we've got DIP28. I know it's the DIP28 DIP stands for dual inline package, which is a standardized chip with legs down both sides that is kind of socketed. And the PLC is a bit more of it's a square chip, and the pins don't necessarily go into a socket. It's like a socket that sits around the chip. So I'm going to click DIP 28, and we can see we've loaded that into the programmer now. Sorry, I had a phone call to take there. So we've got the chip at the top here. We can see select IC, and it's the IC we've selected. And we're going to click read. And you can see we now see a sort of animation, a cartoon, whatever you want to call it, of how the chip should sit in the programmer. And as you can see, it's as far top as it can go, as shown earlier in the video. So pop your chip into the programmer with the U at the top, and if you have it, see here you've got the little circle, that means pin 1. So if you have it, you want to make sure that that's in that direction and pin 1 is there, but this particular chip doesn't have that. Once the chip is in the programmer, you push down on the lever, and that will lock the chip into the programmer as shown here. And now we're ready to read it. So I'm just going to click read, see what we get. Okay, so it's recognized the chip. It's decided that yes, it is probably that style of chip. The ID matches, and it's read the chip in 1047 milliseconds. So once you've done that, we can see that stuff has appeared behind the screen, which is the actual contents of the chip now. So we'll click back, and we can see that it looks like a load of gibberish really. And that's not unusual because it will be compiled in some way, and it probably won't be readable to a human unless it was decompiled. So if we just go through there, we can see lots of different information on the chip, and we could go all the way to the bottom. And what we're looking for here is if it was just dots, like that last line there. See, it says all zeros, so that's like a blank aspect of the chip. But we can see the data is running right up to the end of the chip. So I'm confident to say that it's probably read the chip. That's probably okay. And that was hopefully a successful read. So what you would do now is you would now simply just go save. We're going to save it as a binary file, and we can save it wherever we want. I'm going to save it in, well, let's just be simple. Let's just save it to the desktop. And we'll just call that VX7000 underscore whatever we thought it was, 2.3. We'll call it that for now. I'll come up with a better name in the future. And we'll hit save. And the file has been successfully saved to the desktop of this machine. Now, if we go and have a look, if I minimize the software, go and have a look at the file. There's the file. I can right click, look at the properties of it. It's a 64 kilobyte file, which probably translates to 512 bits, something along those lines. Bear with me. Yes, there we go. 64 kilobytes is 512,000 bits. So that's where the name of the chip comes from. So if the sole purpose for you watching this video was actually just to back up the chip, then you're done. I've shown you how to install the software, shown you how to use the programmer, shown you how to find a chip in this example in a VX7000, and I've shown you how to back up and save that file. Now at this point you may choose to pop that file on an external hard drive, pop it on a network backup system, store it somewhere safe for your own intents and purposes. But I think the more noble thing to do is actually share these backups and store them in a central repository, so that other people can benefit from them. Other people can fix their own devices perhaps that have faulty software, or potentially upgrade their device with a newer version of the software and get more functionality out of it that if they'd have purchased it later at the time, it would have come with from factory. So I think there's lots of good reasons for centrally storing this stuff, because like I say, the manufacturers are not interested anymore. We have a huge movement in the right to repair, which is a completely separate topic. But I've argued this with Bang Olufsen. I've said the right to repair, we have it now, you know, give me what I need. and it's not retrospective. It doesn't cover old stuff. It's only on newer stuff coming in. So we're a little bit on our own with this. So here we have the chip that I've just backed up. This is a chip out of another VX7000. So this label is actually in a better condition, and you can see here this one is software v.12. And you can see that you've got the B&O part number on the bottom there, and the part numbers is slightly different, which makes sense, but the rest of the information is practically the same. So I'm just going to try and get the best angle on that label to get that part number, and then I'll show you what I'm doing next with archiving this. And as a bit of bonus footage, I'll show you how you would potentially burn one of these chips as well, because I think that's quite important as well. Okay, we're back on the computer now, and you can see I've given it a more appropriate name now. This matches what the label says. And like I say, at this stage, if you wanted to archive it yourself personally, well within your rights to do so. But if you want to share it, then that's what I'm coming on to now. So I'm trying to build, at the moment, a central repository for everything that I can get access to, that I have made myself. And I'm trying to do that on GitHub. And that, as I understand it, is the programming method of choice. So if we go to the browser, what we'll do is I'm just going to paste this in, but it's https://github.com, and it's / the Retro Bristolian, which is what I've chosen to call myself. And you can see here, this is very much in its infancy. You can see I've only joined 11 days ago. I'm very new to this. I'm not a Git specialist by any. I'm a Git. Some people might call me a Git, but I'm not a Git specialist or expert or anything like that. So I've just kind of loosely said who I am. You can see even the formatting is terrible. Whyarchive.org is up there, and then that's there. I don't know. And this will come in time. But you can see I've got a repo here, a repository called BO Software. And it is public. And you can see I've got all the gear and no idea. For this example, this is the one I've uploaded previously, VX7000 here, and you can see I've got the bin file for the software version 1.2. And what I will be doing in a moment, off camera, is I'll be uploading the version 2.3, and I'll tidy this up a little bit, add some more information, and show you what I'm trying to do a bit more effectively there. But essentially what I'm trying to do here is upload all of these bin files to this as a sort of directory, as a share. And what you can do is you just click them, and you should be able to download it. And you can see that I've downloaded that file. And what we'll do is we'll just close the browser. I'll go over to downloads, and I'll just move that so it's next to the one we've just done. You can see they're both 64 KB. And what you would be able to do is download this yourself, burn it to a ROM, and create it yourself, which I'm going to show you later. Okay, so I've had a bit of a play about with this now for a couple of hours there, and it looks a bit more presentable now. I've now explained what the point of it is. You know, the fact that, let's be clear, this is not about me. This is about the community. This is about sharing copies of software that would normally be in your device that might be lost due to old age, failing chips, power surges. You know, this is all about the community being able to maintain and repair, you know, the right to repair their devices. I'm not trying to screw anybody over here. I am just literally trying to help everybody and encourage everybody to help everybody else. If you contribute, you know, if you drop me an email and say pop this ROM on the GitHub, on the repository, you're going to get your name on the acknowledgements. I'm not trying to go down the stolen valor route. You know, whoever contributes, they're going to get mentioned. You know, it's their contributions. But there we go. So if we go into the VX7000, you can see, and again, this comes to my point, there's some information here that I would never have known, and this information came from a BA World forum post, and I put the source there because that's what I do. So it's quite interesting. It looks like the known versions is 1.2, 1.3, 1.37, 2.3, 3.1. As we can see, I've now got 1.2 and 2.3 uploaded. I believe I've got 3.1, and I might have 1.3 as well. So it's only the 1.37 I'm missing, I think, from memory. I've tried to capture as much information as possible, so I've said the device that I've used to back it up, what it came from, what the part number from B&O was, and of course what the type of chip is. So it means that when you come to do your sort of thing, or when it comes to burning them, you know what chip you need to buy if you want to replace your chip. They all seem to be slightly different versions. So we've got the Texas Instruments version of the 27C512, and we've got the ST version of the 27C512. Now, I think, based on previous research, that the 20 stands for, it's a response time, and it's either nanoseconds or microseconds, milliseconds, something like that. So it'd be like 200 millisecond response time, and they're both the same. They're both 20, so they're both whatever that number is. I'll see if I can look that up a second, come back to you. Okay, so yeah, here we go. So you can see here, if it's the -20, it's 200 nanoseconds, just for future reference there. So when it comes to buying a chip, you want to make sure that you get a chip that's going to be compatible, so ideally the same type, maybe not the same manufacturer because it seemingly doesn't matter that much, but you need to get the same style of chip, and then you need the, whatever it was, 200 nanoseconds or less. So I actually had a 150 nanosecond chip, and I managed to burn this ROM back to that chip. I should imagine that would work fine, but I'm going to try and test that in this video just to prove that this does indeed work. Here we have two old chips. These came in a package I bought from eBay, and we can see there was a couple of chips in here. There was actually 3. I won't show you the third one yet, but it just came in a little packet. I got it on Facebook Marketplace, sorry, that's where I got that from. And I got that with a EPROM Eraser, which I'll show obviously a bit later on in the video. So these 512K chips, they match, they're both whatever they are, 27C 512. These are the AMD variants, and at a glance it looks like they're all basically the same chip, which would make sense, just different vendors producing them. And seeming, I would imagine, you know, different qualities, what have you. But these are both 200 nanosecond, so they should be compliant with what B&O require. So what I'm going to do, I'm just going to take, let's just take this one. I'm just going to take the label completely off this time now, and we can see this was actually an old Sony chip from something. I would back it up, but I suspect it's probably already been erased and reused a few times, so it's hard to know what would be on there really. So once you take the chip off, then you see the window, and these are what they call UV erasable chips. They're erased by ultraviolet light, and what you want to make sure that it's super clean. So we're going to use some IPA. I'm just going to pour a little dribble into a glass. And see, just a little dribble in the glass there. Just going to use a cotton bud. Just going to start wiping across the face of the chip. Just try and get any gunk, any glue. Try and get that lifted. I did this on another chip, and I found that after a couple of goes, the glue did just lift off. So you ended up with a nice clean chip, which was good. Obviously the main thing we're trying to clean is the window, but it's nice to clean the whole chip, because when you come to doing labels, at least the new label will go on easier. Okay, so here we have the two chips cleaned now, and I've just gone over those obviously with alcohol, and we can see now that the if that will focus, I don't think that's focusing. I'll try. There we go. We can see that all of the sort of glue residue has been removed, so I'm quite happy that these chips are now clean enough, shall we say. I've cleaned over the window. I'll clean over the window one more time, but we should now be able to erase them. So I'll bring the eraser in. So here we have the main thing that I purchased off of Facebook Marketplace, was the eraser. Now this eraser came with, like I say, a big box of EPROM chips. I've got them sat behind me, but they're all mainly sort of 1 to 8K and smaller sizes, which is a shame. There was only the free 512 in there, but I got it at a really good price. The guy was more than happy that I turned up and paid him, and it was no stress. So yeah, it was good all round really. I think everybody won. It does work, which is what I was worried about, but it does indeed work. We've got a little pull-out tray, and you might have heard a little click there. So there's a safety switch to stop the UV light when you open the tray. And then we've got some, I would assume that's like an anti-static foam, and you could pop the chips in like that. Just pop them in. And we'll go for the sort of middle of the tray, which is about there by the looks of it. We're just going to pop that in. Now what I will do is I'll turn it on first. We can see we've got a neon to say that there is mains power, and there's a neon for the UV light. And when I just shut it, if we're lucky, it's too close and it's too bright in the room. But sometimes you can see the UV light just poking out the door a little bit there. So I do know that the bulb is working. Obviously when you shut the door, the UV light comes on. Now this particular model doesn't have a timer on it, so I go for about half an hour. So in half an hour's time, I'm going to come back, switch this off, pop the chips out and test to make sure they are blank. Okay, so I've just popped over my parents, had some food, so it was quite nice. And I've come back, checked the EPROMs, and they look to have erased, so that's good. So I'm now on the computer. I've got two blank AMD EPROMs now. One of them I've popped in the programmer. Start up the software again. You can see we need to make sure that we change it to the right chip. So I've changed it to AMD DIP28. And then this time we're going to do a blank check on the chip. And we'll say blank. And we can see here that it says that the code is empty and the device is blank. So we could also do a read, which would do the same thing. It's going to read the chip. Read successful. I'm going to see here that it's all Fs. It's all dots. And the chip is completely blank. I've done the test with both chips and can confirm that they've both been erased. So now that we know that we have a blank EPROM, we now need to load up one of the bin files and burn it to the EPROM. So I'm going to go load, and I'm going to hit browse, and then I'm going to have a look at my desktop. Here we go. And I've got the 2.3 downloaded. So I'm going to click open. I think we can leave all of this as default. And we can see here what we saw earlier when we did the read of the original chip. And now simply we're going to do a program. So we're going to hit program. Pop in what chip we're using, which is the AMD variant. Confirm that it's in the programmer correctly, which it is. So I'm going to hit program. And we can see now we're burning the ROM to the chip, and it takes longer to burn than it does to read, which makes sense. So just let that run through. Okay, so that says that's succeeded. So what we'll do is we'll click back. We'll do a read. If we read the chip, it looks like it's gone through. It looks fine. Now, Adrian Black of Adrian's Digital Basement, he recommends that you actually burn it a few times. So I'll do a second burn. So I'm going to say program again. Program. Now, of course, if you were burning something different to what was already on the chip, that wouldn't work. But because we're basically burning over the exact same image, it should theoretically be okay. Okay, so as far as I can tell, that's done a successful burn. And actually, I did just see something interesting on the chip that wasn't compiled code. I didn't know if anybody spotted that. There was something about video and VCR and what have you. Oh, here we go. Look at this. You can see text, look. Tape list 4, tape naming. So that's probably, VTape, VTape 2. Probably something to do with the menus. So that's nice to see, because at least you can see that it has read that chip properly. So I'm happy that that burn is successful. So what we can do is we can close down the program now and remove that EPROM. And that EPROM, if we wanted to, would be ready to go back in the VCR. But what it is missing is it's missing a nice label. So I'm just going to quickly show what I've been doing about labels. So you may have noticed that on the GitHub repo, there's also this file that's got, I believe that's LBX, which is a proprietary extension for the Brother handheld label printer. I'm just going to switch to the camera now to quickly show you that. Okay, so here we have the Brother P-Touch E5550W. Now this is a common tool amongst the electricians. They quite like this one because it's good for on the job if you just want to type something in. But it's also got, let me see now, it's also got USB, what is that, USB-B mini. I'll put it on the screen what it is if I've got that wrong, but it's the oldest type cable rather than the micro, more newer standard. But that can connect to Windows or Mac. It's got the options for standard batteries, so it can just take AA's, I believe. Does it say AA's? Yeah, AA alkaline. Or it's got a rechargeable battery pack, which is what mine came with at least. It's got interchangeable labels, and you've got different types. You can have white, black, whatever colour you want. And it's also got different thicknesses. This happens to be the 12mm because that's what I'm going to be needing for the job. So just pop that back on. Now I'm gonna, that's not fitting quite right. Okay, cool. So I'm going to be using this connected to my Mac to get the label off of it. But I just wanted to show and remind everybody what the original labels look like. So that was the version 1.2. That was the version 2.3. And I'm just going to show you the new labels that I've made, because I've got some already printed off here. If I can pick it up, which I can. There we go. So that's what the new label looks like. And then this is what it looks like on the chip. Now I could have printed it full length, but because of the notch in the top of the chip, I wanted at least a little bit of chip showing, but that's personal preference. And the reason you need this is because these are UV erasable. Eventually with sunlight or whatever, they could potentially erase themselves. Now I know obviously in the device it's going to be quite dark, so that would be a slim chance, but I think it's a nice touch to put a nice label on it, so we can see if we compare that to the original. You know, take your pick, which one would you rather have? I think the old label is nice from a traditional standpoint. It's a traditional font and what have you. But I think the new label is nice in the sense that it's clear to read, it's fresh, and it will last for a long time. So I'll switch back to the Mac now and we'll just quickly show what would happen if you downloaded that file and open that up. So I decided to install the software on the Windows machine because I thought that most people would be probably using Windows, so it would be better than looking at the Mac variant. So you can see I've got the PTouch editor installed here, and I've pulled down that label file from the GitHub. So if I open that label file, and we can see here we've got a zoom option. It starts off quite small, but I go up to the maximum, which is 400. And obviously, this isn't quite the right information for this new chip. So I've just popped the information I wanted in the notepad there, and I can see I just need to change that to V2.3, and then the B&O part number is different. So it was 8342605, and if I save that, V2.3, so I can save that one there. Okay, to enable. Sure, why not? Okay, so once you have the label how you want it, we can do a print preview, which is pretty similar to what you would expect it to be. But if you think the label looks right length for the chip. Now what I did do actually is I've physically specified the length and the tape width. So you notice that the text was kind of crushing to the length. So that's how I know that it's going to be the right length for the chip. Could be a bit longer than 31mm, but that ended up being the size that I felt most comfortable with. So I'm going to hit print. I'm going to do auto cut because I'm only going to print one of these, I think. Then you've got properties. Yes, that all looks fine. Somewhere there should be an option to change the quality of it. I don't know if it would be... there we go. Output standard to high resolution. So there we go. Shall I print 2? Let's print 2. Sometimes the printer freezes, which is never ideal. So we'll see how this works. So we'll hit print. There we go, we can hear it trying to come out. Okay, cool. So it has printed 2 labels there. Actually, it looks like it's printed them okay, unbelievably. I think it's my other Windows machine. If you try and print, it will freeze after one print for some reason, but it's an old machine, so there we go. So what we'll do is I'll switch back to the camera now, and we'll show you popping the label on the chip. So we're fastly approaching the end of the video now, I hope. So I've got the chip and I've got the labels here, and you can see it wastes a lot of label, this printer. If you can, you want to try and print in succession, because you can see on the second label you only get a little bit of waste, but on that first one it always does this for some reason, so just bear that in mind. So when you're happy that your chip is clean enough for the new label, what we can do is we can just grab that label, he says. You've also got like a half peel on the back as well, so you can do it that way if need be. There we go. And what we'll do is we'll just try and line this up. It's probably easier said than done when I'm trying not to lean over the bench. Yeah, it's not the best job in the world, but it would do. So we can see I've now got 2 easily identifiable chips. Just pick those up for you. So we can see what they're for and what version of software they're running. What I could do is I could just pop that back in the reader to just read it one more time to make sure it reads okay, but I'm sure it reads fine. And what I could now do, of course, which is what I'm going to do, is rather than put the original chip back in the VCR, I'm going to put the new chip back in the VCR. The VCR doesn't work, but at least I know that it boots enough to check the software version. So I'm going to do that, plug it back in, make sure that it's recognizing the software, and then we know that we've successfully backed up, archived, and burnt to a new ROM, and put that back in the device, and made the device work. So we know that the whole process works. So be right back. Okay, so I'm in the spare room at the moment, and obviously, like I said previously, we're in amongst decorating and such, so I've got the lights off so you don't have to see everything else. But this is an MX8000. I've got the VX7000 plugged into it. I've got it on VMem or VTape at the moment. I'm going to go to the VTape options, and then I'm going to press 00 go. That brings me into the service mode, which is what you can see on the screen now. And if we go to software version, we've got version 2.3, we've got a date, what have you. So it looks like at first glance, we're all good. And I didn't expect anything less. Obviously you can do all sorts of funny checks in here, but the VCR is not working, so it's definitely not going to pass any of that. But like I say, software version, there it is. So thanks for watching. If you've got any questions, of course, pop them in the comments. But hopefully you found this informative, and hopefully it will encourage others to back up their software and potentially put it centrally as well, so that others can benefit from it. I've got one last bit I want to say, so I'll switch back to the Mac. Just before I round up the video, I just wanted to make a point of saying that there are companies out there that offer this as a service. We can see here there's a company called Masterplay, masterplay.eu, and they've got Beermaster 7000, Beermaster 5000, Beermaster 9500, 9000, and we can see here that they've got the firmwares on offer for sale, €42 a piece, or they even offer a copy service as well. Let's have a quick look at this, see what they say. So for €45, they're willing to copy your original EPROM if they're these types, and we can make a copy of it to a new or a raised EPROM depending on what we have in storage, and we can also do other types of requests. So, you know, they offer a full money back guarantee as well. Interesting how they spell warranty with an E. But it's €45. You could argue that the tester, I mean, let me see what that is in pounds. Yeah, okay. So it's not an unreasonable price. But if you've got a couple of devices, that could get quite expensive quite quickly. And you could potentially back it up yourself, get a programmer, back it up like I've shown you. And if you've got some old EPROMs lying around, great. If you can get some on eBay, old stock, great. Having a look, like I say, the chip I've used is this chip here, the AMD. And I just had a look online to see what alternatives are out there, because you can't buy them anymore, because they are ancient. And it seems that the Atmel chip is what they're recommending is the alternative. It's interesting that they call it an EPROM, because they also call it a OTP, one-time programmable, which means it's not erasable at all. But, you know, if this is a one-way trip and you're just trying to burn it to put it in your device and there you go, it might be okay for you. You've got the 70 nanosecond access time, so it's much quicker than the 200 nanosecond original. And we can see that's a like-for-like chip that you could potentially program yourself. And that chip comes in at £2.77. So you can see quite quickly, if you had a couple of devices, you could potentially save yourself a lot of money and do this yourself with ease. So I'm a great believer in repairing things yourself. I'm a great believer in learning how to do these things yourself. And whilst I think these services do have a place, I also find it unfortunate that we have to go and pay somebody for this. You know, I would love to be able to see this software somewhere in the ether, which is what I'm trying to do with the GitHub, where you can get it yourself and do the repair yourself. So let me know your thoughts. Let me know if you think I'm right. Let me know if you think I'm wrong. I do love to see the comments. I woke up this morning to a comment from somebody on my Penta video saying that they couldn't have done it without me, and they really appreciate the video. So that meant a lot, and I've been sort of thinking about that all day. So that was really nice to see. So like I say, drop me a comment, drop me a like, let me know what you think.